uniform class interval or not? And then we decide on what to do. No, those are paradoxes. I want somebody to be boring, and you say it is this. If you inclusive kind of grouping, yes? When it is inclusive kind of grouping, what comes to our mind first before we start doing this? Yes? Be serious, madam. The uniformity and non-uniformity is not connected to the kind of grouping. Yes. When it is inclusive, that's when you adjust the limits, okay? Whole numbers you add 0.5, subtract 0.5, yes? And whatever comes out will be now exclusive, isn't it? Yes. So, apart from that, we have recognized that it is not uniform class interval, okay? The class widths are not the same. An implication that therefore the rectangles of the histogram are not going to be the same, okay? So what happens is that the height of the rectangle in the histogram is exactly in frequency density, not frequency as we used in the previous examples. Okay? And how do we get the frequency density? Frequency over class width. Yes? I want to write what is the name of the group? What is on top? Time. Is it time? Yes. So can we put time here? And then you give me the groups. For me, I'm recording for you.
10 to 19.
10 to 19.
20 to 24.
20 to 24.
25 to 29.
25 to 29.
30 to 39.
30 to 39.
40 to 49.
40 to 49.
50 to 64.
50 to 64.
65 to 89.
65 to 89. Is that the last one?
Yes.
Now, I have frequency here. Do I?
Yeah.
I want to have frequency here. And what is the frequency? 8, 15, 25, 18, 12, 7,
5.
and 5. Isn't it?
Yes.
Now, I want to get the class width. Class width of each class. So what is the class width here? I mean the class number. You are not giving me the answer. What is it? 10. We have 10. Do you agree with me?
Yes.
We get upper class boundary minus lower class boundary. You get 19.5 minus 9.5. Isn't it?
Yes.
I don't want you to subtract and add one of those secondary school things which are not related to anything. The next one, the class width is what?
5.
The next one, the class width is?
5.
The next one is the class width here is what?
10.
And the next one, class width is?
10.
And the class width here? What?
15.
15. The next one? 89.5 minus 64.5. 25. Wonderful. I can now generate the frequency density. And this is the same as frequency over class width. I am calling this one W, isn't it? So what will happen is that I have my frequency divided by the class width. So for this particular one, it will be the same as 8 out of 10, which gives me 0.8. Are we together? For this one, it will be the same as 15 divided by 5, which is equal to 3. Okay? This one will be 25 out of 5, which is equal to 5. Here we shall have 18 divided by 10, which is equal to 1.8. We shall have 12 out of 10, which is equal to 1.2. And then we have 7 out of 15, which is equal to 0.417. 467, okay? And then we have 5 over 25, which is the same as 0.2, isn't it? It's 0.2. What we have got here are frequency densities, okay? They are no longer frequencies. And now the frequency densities are going to represent the height of the rectangle in the histogram, all right? Are you done with this? Yes?
That's the difference.
Okay, you can first write, and then we are going to have the class boundaries. I will show you what I need to put against what, and then we draw the histogram. If you want to write it next, I am going to have the class boundaries now. The class boundaries here, they are going to be 9.5 to 19.5. Agree? Yes. We are going to have 19.5 to 24.5, okay? These are class boundaries now that I'm looking for. And I'm doing that because it is inclusive kind of grouping, okay? And we said inclusive kind of grouping is where the upper limit, yes, is not the same as the lower limit of the next class.
Yes.
Where the upper limit is the same as the limit of the next class, that one becomes exclusive and there is no adjustment, okay? Now when we go here, we shall have 24.5 to 29.5. We shall have 29.5 to 39.5. We shall have 39.5. We got 49.5. We shall have 49.5. We got 64.5. And we shall have 64.5 to 89.5. Is that okay?
Yes.
Now, the histogram I told you is a continuous graph. After adjusting these limits, we get now exclusive kind of grouping, okay? And what ends here is exactly what starts here, all right? Which means after plotting this one, I will be following this one because they are the same as the next ones. Is that okay? Now, we go to, if you have finished, I can now start drawing, all right? I'm not going to be exactly accurate. You have the graph papers, you have to make sure that you are accurate. Your graph becomes very small, okay? You have to look for a moderate, a proportionate scale so that your graph fills 3/4 of the graph paper, okay? I hope we are together. Don't start putting 10, 20, when actually on this axis, the highest value is 5, is it? Are we together? Yes. We shall look at that when you are on the graph paper. So, I am going to try and draw that graph here. I'm going to fit it there. For you, you will draw it very well. We have the vertical axis. We have the horizontal axis. And this vertical axis, we have frequency density. Are we together? Frequency what?
Yes.
We have frequency density. And the horizontal axis, we have time. Yes?
Yes.
Time, is it in minutes, in hours? What is it? Is it in hours? I don't know whether it is in hours. You are the ones who is a question. Time in hours. You have to be serious. And you are really very sure what you are writing there is in hours, in minutes, in seconds. The reason is that should you want to estimate something on this graph like the mode, the answer must be given in hours, yes? In the previous one, we said it was in shillings. Okay? Yes. Don't write a figure as if it is an index. Make sure you give it what it is, because you are measuring. Now, the lower class boundary here is 9.5. Are you there?
Yes.
The next one is what? 19.5. The next one? 24.5. The next one? 29.5. The next one? 39.5. The next one? The next one? 64. You have made a mistake. I want to use the small interval, for example. Okay? If this very small short interval is going from 9.5 to 19.5, yes?
Yes.
And the class width was what? Go back. Class width was what? 10, isn't it?
Yes.
If I put 19.5, I can use, it is better to use the smallest, yes?
Yes.
What is the smallest? In the class intervals, they are all multiples of 5. Go back to the you call for class width? They are multiples of what? If they are multiples of 5, it is better we use the interval of 5 here. Are we together?
Yes.
Is that clear? If you have it, so that means when I start here at 9.5, I will add there 5 and go 14.5. Yes?
Yes.
Because otherwise the scale has to be maintained on the graph. Although the intervals are not equal, okay? If you decide to use 10, you continue using 10, you are not going to go by the class boundaries here. They will have to fall in by themselves. That clear?
Yes.
Can we now use 5 because the smaller it is, the better, okay?
Yes.
Because otherwise if you use 10, that means you will have to bisect it as you draw the rectangle. Okay? Good. That one I'm not very sure you are going to, for you have to look at it. You want to use 10? You want to use 10? How many will they be? You just get 89, yes? 0.5. Hurry up, please. 89.5 minus 9.5. 80. So if you want to use 5, it means you will need 16, isn't it?
Yes.
Because you divide by 16, you divide by 5, the interval you want to use, isn't it? So do we use 10? 16. Because the 16 can fit if you use the small interval, not the where we have 5 spaces, isn't it? Can they fit? They can fit, isn't it? So we are using 5, all of us, all right? Have we agreed? Okay. Now I am going to proceed. The scale we are using 1 centimeter to represent 5 units, isn't it?
Yes.
Add 5.
24.5.
Add 5.
29.5.
Add 5.
34.5.
Add 5.
39.5.
Add 5.
44.5.
44.5. Add 5.
49.5.
49.5. Add 5.
54.5.
54.5. Add 5.
59.5.
59.5. Add 5.
64.5.
64.5. Add 5.
69.5.
69.5.
Yes.
69.5. Add 5.
74.5.
Add 5.
79.5.
79.5. Add 5.
84.5.
84.5. Add 5.
89.5.
89.5. I want to stop there, okay? Now that this one is done, can I remove the other one? Oh yeah. Am I fast? Yes? You are a wonderful class. Now that means I can increase on my speed, yes? I increase? No. And I want to tell you one thing that is very serious. It is not writing. It is paying attention and understanding how you are going to do this yourself, okay? So that if I go away, you can begin and reach the end, isn't it? Now, I want you to watch. The vertical axis, the highest value on the vertical axis is 5, isn't it? So, since it is 5 and you want a bigger graph, I am going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I look at that? If there are 9 spaces, I will have the maximum, which is 5 divided by 9. Yes? What does this one give me? Tell me the value. 0. What? 0. What? 555.
Yeah.
What does that one mean? It means that if my spaces are they 9? If they are 9, I cannot get anything less than 5.55. It has to be higher. Are we together? Are we together? But if for me I have 12, yes, I will have more. Okay? Let me add there like 1 here and 1 here. Those are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Can I make them 12? Okay. Don't mind about the spacing for you have a graph, okay? If they are 12 and we have 5 out of 12, what does it become? 0.04. 0.4, 1. Anything above 0.4 can work. The minimum you can use on the vertical axis for the graph fit is 0.4, okay? If you use anything less, they will see you trying to draw to stretch. But now if I use 0.5, which is higher, I can fit my graph. 0.5. Remember I said it should not be too large, okay?
Yeah.
0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4 point what? 0, 4.5, 5, 5.5.
Yes.
Even if I stop there, okay? Pay attention, don't write anything, just pay attention what you are going to do.
Yeah.
The first interval you have it, I don't have it, starts from 9.5 up to 19.5, okay? It takes these two intervals of 5, okay?
Yes.
If you had used an interval of 10 here, you would start from here, and the one of 5 would be half of it, isn't it?
Yes.
Now, vertically upwards, where does it go? Up to 0.8. If I go line up 3, I come and go here. This has a bigger width than this. The height is compensating, yes? Because the area of the rectangle must be proportional to the height. Are we together? In a histogram, we are not using bars, we are using rectangles. And those rectangles, what is special to them is that the area of the rectangle is proportional to the what? To the height. It is automatic if there is uniform class interval, okay? But if there is non-uniform class interval, for proportionality to take place, you must use the height as the frequency density, yes? Which will be the frequency over the class width. Okay? The next one starts from 24.5 up to where? 29.5. And the height is? 5. That is the tallest, by the way. It is up to that point. Up here. And the interval is just only 5. Yes? The next one is what? 29.5 to? You see it has 2. Because it was 10 in width here, you have 10, isn't it? Now, the height? 1.8. 1.5, so 1.8 is right there, yes? And I will go there. Next. What? 49.5, and the height is? 1.2. On your graph, you can estimate 1.2 to be like there up to that point. Next. And the height? 0.4. And the height is? 0.2. It's something very small, but it will go up to the end. 0.2. I'm assuming that 0.2 is there. And that is the graph. This one is, the width is long, but the height is short, isn't it? And once you have the frequency density, it means what you have got will have, the area will be proportional to the what? To the height. Is that okay? Now, the heading is supposed to be there, isn't it? What heading can you give to that graph? What heading can we give to that graph? I am listening. The scenario talks about what the company is doing. What is it? What was it that we corrected? Where they corrected that? Time? So this is a histogram representing working hours, okay? Of group employees, yes? Working in a particular week. Is the fund mentioned? Yeah, you can stop there. And then the rest, we have talked about how you put it there, yes? If in this particular question, they asked you the mode, then you would come and look at this storage, and you move a line from here to this vertex, and a line from here to the next one. here. Sorry, it should go here. Then you drop a vertical line and you estimate the mode from here. It was asked. Okay. And can I proceed? The question involving a histogram. Number one, you have to identify whether the type of grouping is exclusive or inclusive. When that means whether there is need for adjusting the limits or not, isn't it? Secondly, you have to understand whether it is uniform class width or non-uniform. And if the class width is uniform, then the height of each rectangle will be the frequency. Okay? If the grouping is that it is non-uniform class width, then you have to make sure that you generate the frequency density. Are we together? Which will represent the what? The height, isn't it? And frequency density is frequency over class interval. Okay?
Yes.
Which means you have to identify the class interval of every class. Alright? After that, you generate the frequency density. When you are drawing the graph, my dear friends, you have to make sure that you are using uniform scale on the horizontal, okay? But only marking where the class width will end for each rectangle, okay? Don't imagine that, like we have done here, that there is a bar that is supposed to be from here to here. No, that one is not there, okay? But your choice of the width should be related to the multiples of the class width, isn't it? If they are 5, 10, 15, it means I have decided to choose the smallest which is 5, okay? If you choose 10, it means these ones which are 5 should be half, okay? Because the value will fall in the middle, all right? And then you draw the graph. And there you will have succeeded. So, do not attempt a question involving a histogram without knowing whether there is uniform class width or not. Yes? The three questions that I picked them from the different papers of CPA. Isn't